Now members, we are going to see, we have seen the analytical method of locating roots for the two cases when we are not given the interval and also when we are given the interval. Now we are going to use the graphical method to locate these roots. Now also here we are going to see two cases. So the solutions or values within which the roots of the equation f of x like can be established by plotting suitable graphs. There are two types of graphs we can use here, the single graph plot or the two graph plots. We are going to see what does it mean. Let us start with the single graph plot. This one is when you sketch a curve. Though like come sketch in real, come sketch in you say in paper one. You sketch a curve, say that quadratic curve on one graph. As simple as that. So here the graph, the roots of the equation f of x equal to 0 are the values of x at a point where f of x cuts the x-axis or y equal to 0. So these ones, like we have solved them from lower levels, is that when to get the values of, or to get the roots or the x values for which this function is equal to 0, they are the roots where it cuts the x-axis. And if I'm to give a simple sketch, if I have a graph like this, then these two are going to be the roots. If this is my x-axis, maybe this is a graph like this. So these two are going to be the roots. So if this one is x1 and this one is x2, they are going to always be the roots. Okay, so that's what I'm talking about in that case. The two graph plot here, f of x is divided into two equations, say b of x and h of x. Then both b of x and h of x are plotted on the same axis, and the roots or root is the value of x or values of x at a point where b of x meets h of x. So when this function here, we divide it into two equations, as we are going to see how we divide it. The d of x and then the h of x. Now, you plot this and also plot this. Now, where these two meet, that's where the root is going to be, as simple as that. In most cases, it's better to divide it into a certain curve and then also a line, because a line is very easy to plot. Then these curves we can plot them at your own time. So use the graphical method to approximate the roots of the equation this. Now, I'm going this question you use only one method, but here I'm going to give two methods so that you can see the overall idea. So single graph plot, I select y, be this, then I do this table for x values, these are the y values, and so on. When I plot this now, this is what I get. You see that y0 goes with the 4, 1 goes with the 2, then negative 1 goes with the 6, and then negative 2 goes with a 2. So those are enough points for me to sketch my graph. So then I draw it like this. That's how this curve. I'm not including these values because this is just for explanations, but it ends up to this side at 22 up there, and also at negative 14. It increases down, decreases upwards, then decreases downwards there. Now, you see that? We say where this curve meets the x-axis, that's where our root is going to be. And when you read off this, you see that it cuts it at this point. So the x value at this point is going to be our root. And when you estimate, that it's going to be negative 2.2. So the root is x equal to negative 2.2. This one is having only one root. Okay, when now you come to the two graph plots, we divide this into two parts. So I told you it's better you separate, you divide one into a line and then you leave this one as a curve. So if I make this the subject, I take this side. When I take this side, this one now becomes a positive, this one becomes a negative. So now I call this b of x and I call this h of x. Or you can call this y1 and call this y2. So this is a line, so this is a curve, as you can see there. Now, I need to plot this. You know, lines are very easy to plot. You just need only 2 points. So, when x is 0, this is negative 4. And then when h of x is 0, in simple terms this is our y, then we make this the subject to get 4/3. Now, here you have to be careful on the, okay, let me first, and then I will warn you later. Now, when I put, now you see that this one is a standard curve. For it, it's very easy to plot. You get also its x values. You say when x is 0, what is the value? When x is 1, what is the value of y? Like that. Then also take to the negative side. So, now when you put this curve here is standard. It's going to come, process like that, then it goes that side. Then the line is passing through. This is 1.33, which is the point here. And then this point here, 0, -4. Then you draw it. Then after also sketching this, so that all of them are going to meet at this point. Now, at this point where they meet, you come and read off your x value. And so they are meeting at the same exact place. This curve meet y-axis, and so these ones are meeting at the exact place of the x value. That's what I mean. So they are meeting at the exact value of x. This curve cuts the x-axis, I think you see. So this is also giving you x equal to -2.2. The same there. Now, the one thing on this is, if you are getting these values in a table, you make sure that you can plot them. You can't give to 4 decimal places, because you can't plot 4 decimal places in that graph. You can never. So now, start this 4/3. So I give this to as 1.3. Why? Because I can look for this 1 decimal place at this. So that's why I have 1.3 there. But if I can't give this to 3, because if I give it to 3, I can't look for 3 on that graph. So or in most cases, either give to 1 decimal place or to 0 decimal places. Or you can give to 2, as long as you can read those things on the graph when you are plotting. So that's a warning that you must take there. So that's it. Now I'm going to give my examples about this 2 graph method, because this one is very easy. People can sketch curves. Now I'm going to concentrate much on this in the next lesson. So you're there. But please don't forget to subscribe to the channel, this channel here.